Welcome to MzansiNumerics. So today we are going to focus on problem type 1. In the first video we went through the introduction to vertical projectile motion and the basics, and then now we are starting on the first problems, and we're gonna do it on the problem type 1 and also its problems. So we're gonna do a few question papers, and then in the next video we'll go to problem type 2. So what's problem type 1? Is a projectile dropped from a certain height. So we see on a certain height a ball is dropped. So let me clean my space so that we can work with this problem. So let's say already type 1. Type 1 is dropped from height. Dropped from height. So let's take it for example. You are on the top of a building, and then when you are on the top of a building, you mistakenly release or drop your phone. When you drop your phone, the phone will go down. So what you need to know here is that because a projectile is a motion in which the only force acting on an object is gravitational force only, Fg. So because Fg is pulling the phone downwards or pulling the object downwards, we'll see that even the object will accelerate downwards because of gravitational force, which is acting downwards 9.8 meters per second. So as well as the phone goes down, the velocity will also increase, and then it will increase maybe here because it is dropped, velocity is 0. It's gonna be 1, 2, 3, 4, 5, and then the maximum velocity will be when the object is about to hit the ground. So one thing you need to know is that when you hear the word dropped, or rest, or from rest, or you hear the word released, know that the initial velocity equals to 0. Initial velocity equals to 0 when you hear this word. What does it mean? It means that that ball was at rest on your hand when you were holding that ball, or when you're holding that phone above the side. And then when you release your hands, that's when the ball will start to go down. It starts from a velocity of 0, but velocity increases as the ball goes down. So you have to be able to name your variables in this scenario. In this scenario of when you drop an object, so your variables are vi equals to v, and then let's say g, and then let's say change in y, and then v final, and then change in time. So the first thing you do before you want to name variables is to choose direction. Let's choose up as positive. So meaning that if up is positive, down will be negative. So because this ball is going down, the initial velocity is 0 because it is dropped, but it was going to be also going down if the ball was thrown at a magnitude. So 0 is neutral, we don't put a sign on 0. And then, but gravitational acceleration, it's when the earth pulls an object down towards the center. So this one is always downwards. So because up is positive, it means that down is negative, and then we put negative 9.8 meters per second squared. And then this distance covered by the ball will be equivalent to the height of the building. So because the distance is being covered going where? Going down. So that's why here we put negative, but we do not know any units net yet. So the final velocity will be the velocity just about when the ball hits the ground, and it will be the maximum velocity because due to our gravitational acceleration, the ball is going to increase velocity as it goes down. So when it's about to hit down, So it will have its maximum velocity, which is known as the v final, and it will be downwards. So it's minus, up is positive, down is negative. And then the change in time. Change in time is a scalar quantity, has no variable, so it's a question mark for now. So now we have done the problem type 1. So let's do problems containing this problem type 1. So here's a problem from I prepared from the question paper. I like to, when I work, I put the formula sheet to the side so that when I list my variables, I know that I look to say that which formula applies. I check they usually give us all the variable except one. So I check my formula sheet and check which one can I use. So let's read the scenario. It says that a ball is dropped off from rest. What do you know about dropped off from rest? It means that v equals to 0. And the v, when they drop it, it means that it was from rest. It was not moving. So the initial velocity there when it was being dropped is 0. And then they say that from, let me say v initial, they said from a 25-meter, this is a information high building, and then the from 25-meter high above the ground, ignore the effects of air friction. Why do they say ignore the effects of air friction? Because what projectile or free fall is when an object moves under the influence of gravitational force only. If there was going to be air resistance when the ball goes down, it will be pulled up by air resistance, and there will no longer be gravitational force only. So because there's only gravitational force, the object will accelerate downwards. That's why they are saying we must ignore what? Air friction. So what's a projectile? A project is an object that has been given initial velocity and moves under the influence of gravitational force only. Now what is free fall? Free fall is the motion in which the only force acting on an object is gravitational force. So, and then let's go through this one. So calculate the velocity of the stone when it hits the ground. So what I like to do before anything, I draw my scenario. When I draw my scenario so that I can see what's happening. So let's say this is a 25-meter high building as how this scenario has told us, and then they say that a ball is dropped. So, and then what else are we given? We are given initial velocity, which is from rest or 0. So after drawing my scenario now, I list my variables. So let me start with vi, gravitational, and then change in y, and then v final, and then change in time. And then I start to name them so that I can see what am I given. So let's see. Let's first we have to choose direction. Let's choose direction. Maybe up is positive. Why do we choose direction? So that when we get a sign in our answer, we use it to determine the direction of where our object is moving. So initial velocity is 0 because the object is from rest. It's going to be m meters per second. And then gravitational acceleration, if up is positive, it means down is negative. So gravitational acceleration is always down. It's towards the center of the earth. So it's negative. It's a constant 9.8 meters per second squared. And then what is the distance covered? From here to here, they're saying that we must find the final velocity here when the ball hits the ground. So from here to here, what is the distance covered? It is the height of the building, which is 25. People tend to forget that this one is also a vector. It has a magnitude and direction. So when the distance is covered going where? Going down. And then if up is positive, it means down is what? Is negative. We put negative here. Final velocity is the velocity when it hits the ground. That's what we are calculating. So it will also be negative because it's going down. And then we put a question mark because we are looking for it. Are we given the time? The time we are not given. So let's see a formula which we can plug all these variables, and then we find the v final. So this one you cannot because there's time. Let's come to this one. This one you can because each and every variable is the final velocity. We have it initial, we have it acceleration, change in y. So let's plug it, let's write it it's v final squared equals to v initial squared plus 2a change in y. So let's plug, and then in the position of here we put 0 squared plus 2 into negative 9.8. When you plug, do not forget to plug the sign. Don't forget to plug the sign also. It's very much important. If you don't plug the sign, you'll get a wrong answer. I usually don't like to round my answer before getting to the final answer. So let's just do it like this. So when you do a square root of inverse, you put a plus or minus. When you do the inverse of square, and then you put this, and then you have 25. And then let me press the calculator to see what we get. So, and then 2 into negative 9.8 into negative 25. Okay, so here we must note the sign. Where did it? Up is positive, down is negative. Final velocity will be going down, so meaning that it's gonna be negative. So it's negative 22.14 meters per second squared. And this negative is gonna turn to a direction. It's negative is 2.22.14 meters per second way downwards, because up is positive, it means down is negative. And then let's go to the second question. It says that how long will the stone be in the air before it hits the ground? So how long? They are looking for the what? For the time. So here we have to substitute what we know now, 22.14 meters per second. So we know all this. So which formula can we use? This one, VF, V initial A, this one we can use this one. Let's see if we can use this formula. V initial change in X, or let's because we are doing the vertical plane, let's check this one. Change in Y, we have it. V initial, we have it. The time we are looking for it. This one, the time we are looking for it. So this one we can also use it, but we are going to factorize, or we are going to use the quadratic formula. This one is a long way, but it's going to give us 0 and also the answer. So this one we can use it, but it's complicated. And this one we can also use it, this one. So, but because because the other one are complex, let's just use this one. So let's take our formula and plug in what we know is V initial plus A change in time. So let's come to this one. V final. V final is negative 22.14. Don't forget to put in the negative 22.14, this one, and then it is the velocity when it hits the ground, and then the initial velocity, because it was dropped, is gonna be 0, and then the initial the acceleration is 8, and then 9.8, and then the time we are looking for it, and then now we're gonna let it be negative 9.8 change in time minus 24.14, and then we divide both sides by negative 9.8. This cancel this, and divide both sides by negative 9.8, and then we're gonna have our change in time as 22.14 over 9.8 is 2.25 seconds. 2.25 seconds. So it takes 2.25 seconds to reach the ground. It takes this 2.25 seconds in the air. So this is our problem. So let's go to the second problem. So the second problem, if you wanna pause to do it, you can pause to do it. Let's check it. So it says that an object is released from rest at point X. So we must know that released or from rest, it means that the starting velocity here at point X, V at X, is what is 0 meters per second. And then it said above the ground, as shown in the diagram, it travels the last 30 meters BC, which is this one, the last 30 meters BC, in 1.5 seconds. So from B to C, we are told that it takes what? 1.5 seconds, and then before hitting the ground, ignore the effects of air friction. So let's check here. Let's check the question. It says that name the type of motion described above. What's the type of motion? So the type of motion is what? There's no air friction, there's no other force, and we see that it's going down. And when there's only gravitational force acting on an object which is above the sky, we call that type of motion what? Free fall motion. Free fall motion. And then projectile, you must be able to differentiate between free fall motion and projectile. Free fall motion is the motion in which the only force acting on an object is gravitational force. Projectile, it's when the object is given initial velocity. So a projectile focuses more on the object, and the object doesn't start from rest but is given initial velocity and moves under the influence of what? Gravitational force only. Now let's go to 2.2. So that now calculate the magnitude of the velocity at point B. So the magnitude of velocity at point B. Another thing of velocity here, another thing which is very much important, we are looking for VP. Another thing which is very much important in vertical projectile is to be able to use section, is to be able to understand section and know which variables belong where. Look at this 30 meter. This 30 meter is from B to C, meaning that if you are working with a space from B, from X to B, you cannot use this. This time is from B to C, meaning that if you are working with the motion from X to B, you cannot use this. So let's check which motion do you want to use. They are saying that calculate the velocity of B. So the section of motion that we have to use, let me draw that it's X, B, and then C. So if we want to calculate the velocity here, so we have to choose the section of motion which consists of B. We cannot do this, use the whole motion of the ball to calculate, because what? Because there is no B. We have to find, if we use the whole section of motion, velocity at C will be our final velocity, and velocity at X will be our initial velocity. If we can also, what we can use is to divide the motion into parts. Let's say we'll say from X to B. That's when the velocity at X will be the initial, the velocity of B at B will be the final in this section of motion. And then we can also use the section of motion from B to C, and then the velocity of B in this section of motion will be the initial, and then the velocity of C will be the final. But let's see, the one that will determine whether we are using this one or this one is the amount of information we have. If we are given more information here, we can use this one. If we are given more information here, we can use this one. So let's see how many information we are given. So let's start from X to B. From X to B, we are looking at the velocity that the ball passes at what? At VB. So looking from the motion from X to B, from here to here. So looking at that motion only, V initial, because the ball is dropped off from rest, the V at X is equals to what? Is equals to 0. So it's 0 meters per second. And then the another variable that we are given, and it's always there, it's okay. Let's choose direction up as positive. If up is positive, it means down is negative. This gravitational acceleration is always down, so it's negative 9.8 meters per second squared. So what else are we given from in the section of X to B? We are dealing with the section of X to B. This let's check the change in y, the distance covered from X to B. We are given the distance from B to C, meaning that the distance covered, it will be covered going down, but we do not have any value of it. When we check our V final, let's check our V final, is the velocity when the ball comes here at B, is the one we are looking for. So because it's the one we are looking for, and it will be covered, it will pass B going down, So we are looking for this one. So what else are we given? The time. The time we are given is from B to C, meaning that we do not have the time from X to B in the section of motion that you are working on. So the time we also don't know. So we are given just to these two variables from motion of X to B, meaning that we cannot use this type of motion from X to B, meaning that here we cannot use it. What we can, let's see if we can use this one and this one from B to C to find the velocity at B. But the difference is that here, because we are starting from B, B will be our initial velocity and at C will be our final velocity. Now let's look at that from B to C. Okay, let's work from B to C. And then from B to C, our initial velocity will be velocity at B. Now, do we have velocity of B? We do not have it, but if up is positive, down will be negative. As it means that it will pass B going down, meaning that it's negative. But what's the magnitude? We do not know. We are looking for it because we are dealing with the motion from B to C, meaning that our initial velocity will be the velocity of at B, because we are learning on how to divide section of motions. And then let's see if we are given the rest. Gravitational acceleration negative 9.8 meters per second squared. And then let's check change in y. Change in y equals to are we given the distance covered from B to C? Yes, we are given. Distance is covered going where? Going down. Up is positive, meaning down is negative. So it's covered going down. How many meters of distance is covered? Is 30 meters. And then what else are we given? Final velocity. We are not given final velocity because it's the velocity at C. We are not given. It will be covered going where? Going down, because we see that when it comes at C, the ball will be going down. It will still going down, but we don't know the value. What else are we given? The time. The time that takes from B to C is what? Is 1.5 seconds. So we are given three things: the gravitational acceleration, the distance, and the time. Let's see if there's a formula that we can use. Here we don't have a V initial, a V final, but we are looking for V initial, and we are also looking for we are also looking for uh, the time. Do we have the time here? Um, the time here we have it, but this formula we cannot use it because we do not have the V final. And but if we can either use this method. We can use this method if we want. If because here the question says that calculate the magnitude of the velocity at B. So we can start to use this one. We are looking. Okay, let's see which formula to use. Let's check this formula. This formula, let's see if we can use it. V final. If you are checking from the motion from B to C, from here to here, the final velocity will be when it hits the ground. So we do not have a V final. The initial velocity is the velocity we are looking for at velocity I. So this one we have two unknowns. We cannot use this one. So let's come to this one. This one, the distance covered. Yes, we have it. Yes, the distance covered. And then when you check to the initial velocity we are looking for it, the time we have, and then the acceleration. The acceleration we have, and then the change in time we have. So we can just write it. Let's change in y equals to v initial change in time plus half a change in time squared. Okay, so in the place of v initial, or let's substitute, we're just substitution here because we're using the motion from B. to C. And then let's substitute. So when we substitute, here we're gonna put -30, which is the distance covered, and then V initial, we are looking for it, and then the change in time we are substituting 1.5, and then plus half into -9.8 into 1.5 squared, and then we just make V. Substitute the formula from here. It's just mathematics, so it's gonna be -30, and then it's gonna be plus half into 9.8, then 1.5 squared over 1.5. So this is just mathematics. You can make it out on your own, and then we say -30 plus. So the reason why I didn't press the calculator in the middle, I like to first uh, write down, and then I'll press the calculator when I'm done, because I will get rounded off answers if I press the calculator anyway, and I'll find a lot of commas, and then my answer is gonna be off. And then this is it. So this negative just means downwards is gonna be 12.65 meters per second downwards, because up is positive. And then this is our answer, and then it means here, because it was our V initial, is gonna be 12.65 meters per second downwards, but we write it with what? With its negative. And then from motion from X to B, when you check this motion from X to B, from here to here, because we found the velocity of at B as 12.65, it means that from this portion of motion, it's gonna be our final velocity. And then from X to B, and then as our final velocity is gonna be 12.65. And then after we go to the second one, let's see what the second one needs us. Now the second one needs us calculate the height of the point X above the ground. So where's point X? Point X is the X, then there's B, there's C. So they want this height. Which height are we given? We are given this one of 30. So there's one way to do it is to find the height of the whole motion, and then you will find height of X, height of X above the ground. So this one needs you to know the velocity at C. We don't know the velocity of C, and then we do not know the time it takes for the whole motion, because the time that we are given, it's only the time for this motion. So which is 1.5, and then we do not have many information about using the whole motion. So that's why I that's why we cannot use the whole motion. The way to use the whole motion is to first find the velocity of C. How do you find the velocity of C? Is to first focus on motion from B to C, because from motion B to C we have a lot of variables. Like these are variables from B to C. We can just come to find this final velocity. We can plug in and find this final velocity, and then after finding the velocity at C, we can just use the whole motion to find X to what? To C. But that one is a way. And then another way to do it is just to find the height or the displacement during X and B, and then when you find it, you add these ones, and then they will give you the height of X above the ground. So the way that I choose, or maybe you can do them both, but let me choose the one where we find the height of X above B, and then we'll add this one and this one. So to deal with motion from X to B, let's check what do we have. So the formula that is simple and straightforward is this one. So it's gonna be V final squared equals to V initial squared plus 2A change in Y. Let's see the variables that we have. We are just listing our variables. Note that we are using only the motion from, let me wrap a little bit here because it's a bit messy. Okay, let me just have it. But so now looking at from x to b using this type of motion. So from x to b, our final velocity is what? Is 12.65 squared, and then our initial velocity is the velocity at x. Now this ball was dropped, so it's gonna be this one, and then 2 into, I just listing these variables, into negative 9.8, and then changing y. We solve the change in y from there on. It's just gonna be mathematics. It's gonna be changing y is equals to 12.65 squared, and then divided by negative 19.6, and then changing y is gonna give us 12.65 squared over negative 19.6, and then it gives us what? Negative 8.16. What does this 8 tell us? This 8 negative tells us that it's the direction. If up is positive, it means down is negative, so it's just 8.16 meters downwards. But direction doesn't matter at this point. Okay, so I went to the problem type 2 that we are going to do in the next video. Here we're only doing type 1 downwards, and then now we are looking for x above the ground, and then we have find this one to be 8.16, and then we're gonna add this and this. So it's x equals to the height from xb plus bc, height bc, which is just gonna be 30 plus 8.16, and then 30 plus 8.16 is going to be 48.16 meters. So this is it. Another way to do it is that one that we suggested, or we just first find the velocity of c. Let's just do it and see. Okay, end up this, and then we'll see if we'll get the same answer. This information I still want it. Let me not write it. Okay, so now I said already, because we are looking for x above the ground, so because we are looking for x above the ground, let's see this one. So we're just going to look at the displacement of the whole motion. So we need what? We are going to use this formula, this one. When I use this formula, v final, when we're using the whole motion, squared equals to v initial squared plus 2a change in y. So we're looking for the change in y of the whole motion. Acceleration we have, v initial we have here, but v final we don't have at v at c. So we are going to find v at c, and then after finding v at c, we just come back and plug to this formula. So how do we find v at c? We use this section of motion bc. Then when we use motion bc, we'll just find v at c, and then we come back and substitute. So let's use this formula. So vf equals to v initial plus a change in time, and then v final. At this point we are looking for it, and then v initial is the velocity at b, the one that we calculated, is going to be what? 12.65, and then we put it with its what? Its sign, which is negative. Down is up is positive, down is negative, and then we say negative 9.8, and then the change in time for this, we are just substituting this from a b to c, and then we find 1.5. And when we find 1.5, we press our calculator, negative 12.65 into minus 9.8 times 1.5. So what do we get? We get negative 27.35 is the one. 27.35 is the final velocity here. So what do we do now? We come back and plug into this formula and use this velocity of the whole motion now. when you use the velocity of the section of the whole motion from x to c, the whole motion, and then from x to c, the whole motion, we come and say that, let me wrap this, and then so from x to c, we're gonna use v final squared equals to v initial squared plus 2a change in y. So the v final, we got it to be negative 27.35 squared, and then the v initial from the whole motion from at x, it was dropped, and then plus 2 into negative 9.8, and then change in y, we are looking for it, and then we come, let me make a small space. Let me just write this side, and then after that we make change in y, submit the formula. You're gonna have 2 into negative 9.8 to change in y equals to negative 27 into 35 all squared. Then we divide both sides by this one, 2 into negative 9.8. Then we divide both sides by 2 into negative 9.8, and then change in y equals to this divided by this. It's gonna be let's see if it will give us the same answer, because physics has many ways to do so. So let's prove the answer. If which one is wrong between these two, I'm pressing the calculator, or if they're both right. So I got negative 38.16 meters, which is similar as not. Oh, sorry, this one, 30 plus 8 is 38. So it's 38 into 1,6. You see, it's 38. So that one was wrong, but I didn't add correctly. You see, I didn't add to say already. Now we had found 30 plus 8, and then I said 48 because I was trying to use my head, but it was wrong. So it's 38. So here I got 38. I was surprised for a moment when they were wrong. So the other way, there were two ways to do it, from x to b to c. Because we were given this one as 30, we first found this one to be 8.16, and then we add them. And or the other way was just to use the whole motion to get this, gives you the same answer. So thank you for watching, and see you later.